All right. Y'all thought I forgot about you, but I did not. I did not forget about you at all. Another day, another Leetcode. Okay, so we're going to do binary tree paths. Given the root of a binary tree, return all the root to leaf paths in any order. Okay. So I guess this is also going to be some sort of a helper function. I could do an in-order traversal. I could do any sort of traversal. And when I hit the leaf node is when I could return a path. I guess that's the case. We'll see. So 1 2 5 1 3 1 2 5 1 3 1. Okay. And it has to do that fucking dash. This is not good. Okay. So one two five one three, and then if it's just a root on its own with no children, return the root. So I can do that. I could do that. So as usual, there's always some sort of base case reference. So number of nodes in the tree range 1 to 100. So if I'm at one node, I can just say if root, there's going to be a minimum 1 nodes. So root dot left return f string root. Why do I do an f string? Because I have to dynamically put the value of that root in the in a string. So I don't know what the value is going to be, so I have to make it dynamic. F string, I can go root.val, and then it'll just put whatever that value is in a string format. And then somehow I'm gonna have to figure out how to do this with what's it called? With these arrows. And the dynamic thing that I could do with the arrow is just like whenever I add a new element, I just do that, right? Because it's dynamic now. And then I could just add segments of these new dynamic strings with the arrow attached. The other thing is, do I want to, what's my time? I have 4 minutes. Okay. We might have to use ChatGPT. Let's define a helper function. Def helper node. It's going to take a node and it's going to take it's going to take a result of all the paths, because I want to return all the paths in this helper function, then return the result. So it's going to be result. What I'm going to do is result equals an array that I'm going to feed into final. Actually, no, I could just do this. Result is an array that I'm going to feed into this helper function. And then just return the result. Because this helper function is going to do work on this result array as we go. So I'm going to take in an array. Let's call it R. Fuck. I took a lot of body shots in kickboxing, so my rib is fucking busted. That's why it hurts to breathe. I got rude Avel. Okay, cool. Fuck. Okay. See, this is real dedication. It's like, no matter how the fuck you feel, get the question done. If I could do it after an ass whooping, you could do it healthy and sober and whatever the fuck. I don't know. I'm just ranting. Okay, if I hit Swift node dot left none and node dot right equals none, right? This is the point at which I want to append basically, I want to know if it gets the root node. If it's not the root node, I can add one. I can add the node so it hits the base case, the final node. And then when it gets the final node, it's not going to add an arrow at the end, and it's going to add the whole item to the array. So what I'm going to do is I'm going to create a temp array that's going to fill as we go. See, that's the thing with this result array. Because temp is going to keep adding. But I need a way to save the memory in temp and keep going. So what I could do is I could just make result equal to helper. Array and return the result after this. Then I could go temp. So whatever my array is in here, so my array, so I'm gonna say result. I'll call it result because that's what it is. Result is the empty array that's passed in. Right? So I have to define my base case. When I get to the final node, I want to go result The only thing is, it's gotta append to a string. I could return all the arrays, right, and then just make the string. And then if it's the final element, just don't add a arrow at the end. I think that's the simpler way to do it, right? I just return arrays of strings that are the right one. And then I get a result, which is an array output of an array of nodes. Then I manipulate each one, so I go through each node, then turn these into strings, and then return this final array of strings. That's what I could do. So result, I guess for each iteration, I have to make a temp array and add that value. Temp equals an empty array, and then result dot append temp. So I keep going, I keep adding to temp. It's gonna be temp, 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 temp. So it's gonna be 1, 2, 5. Then there's gonna be an array that's 1, 3, and then that appends to result. So temp. So helper root dot left, and then I'm gonna go There's gonna be helper root dot left, and I have to keep accumulating on temp. It's weird. I don't know how to structure this. I'm getting kind of lost with recursions. So it's gonna be root. I know for sure I need to take a final array and return it. So I could have that there. So I could have a resulting array and a temp array, which are both so I could have a final array because I need two arrays. I need one to fill, and then I need one to accumulate while I'm filling, and then take the accumulated and fill it with the fill up ones. So we can call this temp. I could have temp here. Temp just adds to itself from every appendage. What's the time? I'm like getting slaughtered by this. It's at 15 minutes. Okay, I have 5 more minutes. Like I said, I'm gonna give myself 20 minutes to do this. So temp equals this, final equals this. Okay, let's just try not to overthink things. Temp, boom, final, boom. I'll also call this temp and final, temp, final. Okay, boom. So empty, empty. Upper root dot left, temp dot append. Node val, right? And then helper root dot right. I could just reduce this to if node dot left, if node dot right. Because I notice node dot right is not equal to none. Append that, final, so it'll be node temp dot final. So that's good. And if I get to the final node, then I go result, so final dot append temp. Then I just go to return, and it returns back, and it keeps going through all these until it hits all these end nodes. It only does it when it hits an end node. I append final, the temp to the final array that's always empty. But then I return this to the main function. I return final, which is the accumulated array of the mini arrays that I'm accumulating. So the total array of all the mini arrays that I'm accumulating here. So it only gets added on final nodes, so leaf nodes. Now I go back to here, I get my result, which is, it's going to be an array of nodes. So it's going to be an array of values. So node.val, node.val, node.val. Now I got to turn that array of values into I got to turn it into strings. So we already know if there's going to be one node, it's going to do that. If there's going to be more than one node, now I'm going to go if so now I'm going to go for in range 0 to length fuck my ribs result. Oh my god, that's painful. Okay, so now I'm going to go through each mini array in this accumulated array of subarrays. So basically now I have, so you see how it says 1, 2, 5 in as a string. Right now I'm going to create a string. I'm going to call this temp. Oh no, it's called temp already. So I'm going to call this temp str, and then I'm going to create a so this final is returned. I get a result of a subarray, so it's going to be 125 as an array. I have to turn this into strings now. Into strings. Okay, so let's go. Let's call this end. It's going to be an array as well. You see, I'm just like doing this on the fly, so bear with me, guys. I know I'm not perfect, but I try. I'm trying my best, okay? So temp string equals, I get a string here that I'm going to insert. So now I'm going to go for each element. So now I'm going, each element is the actual array, so I need to go into that array again. So it's going to be event squared. So now I'm going to go for I. Oh, 4j in range 0 to length of the I element. So right now I'm going to the length of result. So now I gotta go result the element of that. So let's go to the whiteboard real quick, because I know it's getting kind of complicated. And you have to track all these things in your mind. So kudos to you guys for like really sticking through it. So right now I have an array, and it's got like 1, 2, 3, 1, 2, and then let's go like 8, 9. So like, let's say there's an array of 3, right? So right now this first for loop in temp, so when I go for I at 0, I'm actually looking at a full array. I at 1, so 0, 1, 2. These are full arrays within my big array, right? So that's why I go length at result I. So now I have to look within this array. So now I'm looking at this array. And I have to turn this into a string, 1, 2, 3, and I have to correspondingly do that with this, so 1-2 string, and then 8-9 string. So this is what I'm trying to do. So this is what this double for loop is. The first for loop goes through the big array. Second for loop goes into the minutia of the small array, converting 2 strings, and then we get our result, which we're feeding into end. So now I go if we're on the last element, if j equals len result, because this is the array we're going into, len result, so last element, I, and then this is a non-inclusive, right? This is a non-inclusive thing, so it's going to be -1, but here we have to manually do it. So -1 to tell us it's the last element, then temp underscore str plus equals f string just the J. Not J, but it'll be result of I, the J element. Because now we're going within this array. So result of I, so 0, and then which element in here is J. So it could be 1, 2, or 3. See what I'm saying? So you have to really keep track of what you're doing. And then we can reset. So after I do this, when I get to the last element here, I want to append to end. End dot append. Temp str. So we accumulate this temp str. Right, till we get to the final element, we append it, and then we reset it. We'll reset it here, just to keep it nice and clean, and then it goes to the next iteration. And temp str equals this, we reset it, and then we break, just to make it nice and clean. You know what I'm saying? I don't even want it to visit the next item after the if statement. And break just takes you out of this for loop. Because continue goes to the next break, will take you out of this, then this will go to the next iteration. Right? Return actually returns the whole function. So you don't want to use return here. You just want to use break to escape the current loop that you're in. Okay, so then when we're not at the last element, we want to go temp str plus equals, right? Temp str plus equals f string. We have to include this stupid arrow. They just made it unnecessarily complicated. So you have to go temp thing dynamic. We'll add the arrow after, and then we add result I at j. So until we get the last element, we have to keep adding this arrow. Get to the last element, we just add the last element, append it to the end string, which is the final result that we're hoping for, which is this, and then reset the temp string for the next, and then break. This should be the solution. I think it's pretty good logically. At least I explained the logic behind it. It might not be perfect, it might not even be right, but this is, I'd say, a decent solution. And then when we go to the next, it's going to keep iterating. So let's say now it's going to go to the next array, iterate, generate string, next array, iterate, generate string, and then we return end. Let's try running it. I'd be so surprised if it works on the first try. I'll be so happy. Please. Oh. Return root invalid syntax. Return root f string I have to return an array of strings. Let's call it root string just to see if it works. And that's an f string. This is like a syntactical issue. Then I just return root string. Does that work? Can I do that? Why? Why can't I do this? Why does root string not work? Invalid syntax, f string. Why is this invalid syntax? Root.val. I want to put this in here. F string. Let's go Python playground. Let's check it real quick. I just want to see why it's not working. So I go x equals f string. Why does this not work? Okay, f string. Y equals 4. Let's just say that, f string. Then for y in the f string, print. I just want to see why x is not printing. Okay, so there's something to do with the f string that's I'm not doing correctly. So let's go look at f string. F string in Python. Boom, f strings in Python. How do you use them? F val. Maybe I'm not supposed to use f string. This is just a print. Let's see. F string. Python offers a powerful feature to simplify formatting interpolation. It size to expand variables directly into strings. Okay. Interpolation simpler. Okay, cool. Embed Python expressions inside literal format. Okay, yeah, that's exactly what I'm trying to do. Why can't I print an f string directly in Python? F strings are giving syntax error. Okay, why? Old version of Python. Literals have been added since 3.6. Okay. Yeah, so instead of using this, use print dot format. Oh, you see, they want you to use this literal notation. Maybe let's try that here. I just want to test it in code Python. So it's gonna be f. It's not gonna be like this. Dot format. Okay, so dot format. So all I have to do is this. Take out the f. Format. Y. You see, so dot format y, this is the variable I want to insert, and it'll automatically reference this. So this, see, it's a version issue. Okay, so all I have to do is go back to this and correct it. Change this to formats. Format, root.val. Get rid of the f string. Get rid of the root.val, and now it just looks at these brackets. Let's run it. I just want to see if it goes to the next one. You see the next f string. So all we have to do is just format it. I think it's an older version of Python, so you have to use dot format, and then I take result I. We place it in here. Then we delete these f strings. So what I'm going to do is format, delete this f string, add this, and copy this. Everything is the exact same here, except we add an arrow. Control C, Control V, and then arrow. That's it. Okay, so the same thing. Do I have an issue here? No. So I'll need to correct it here. This should fix my f string issue. Helper root.left, helper root.right, node final, runtime error, root is not defined. That's why. So I have to use node. Instead of root, I have to use node. This is good. See, it all goes back to your syntax and understanding of it. Let's try this. Come on, come on, come on. Come on. Has no attribute get item. Has no attribute get item. Built-in function has no attribute get item. No dot left. Temp dot append. That's why. Temp dot append node val. That's why. Temp dot append node val. See, I'm just like fixing it as we go. Let's try that. Why won't this work? If node is not equal to none, node val final. Pass in my final. Final dot append temp, which is accumulating here into here. So why? None type doesn't have an attribute, okay? What about if node.write is not equal to none? So let's see what time we're at now. 36 minutes. But I showed you guys my logic. So hopefully maybe ChatGPT can correct this. But this looks pretty sound. You guys understand why I did what I did. I explained my logic. The rest is just syntax and bullshit. So let's take it to ChatGPT. It's all about being efficient. So first let's go get the description. Instructions. My code. Fix my solution. You just need to address a few issues, optimize code structure, use the revised version of your code. Okay, so let's see. Okay, so they got rid of the helper. Oh no, they didn't. Oh, okay, so they didn't get rid of the helper function. DFS. Oh, okay, fuck. We have to go DFS. Is this even? Is DFS built in? Okay, so let's check. Explanation cases. Okay, so if not root, return. Okay, so format root.val. Okay, so that's correct. Then self.help, and then this final. Okay. So what is going on with my node? Node equals temp plus node val. Okay, so this is the issue in the code. Temp plus node val. We should append node val. Node right, node left. So let's see where this goes. Oh wait, why did I open VS Code? So let's go to my code. We can pretty much leave my code the way it is for this. Temp. So this is all the same. And all we do is we leave these arrays as is. We reserve these to traverse, like it's doing here. If node.left, if node.right. And it reduced what I said, like I said. So if there's a node.left, do it. Because we're checking if it's not equals none. We might as well just check if it's there. So if this, do this, right? And then all they did that was different was they just add the node in any case. So temp. And then in this case, the final only appends it. So temp equals temp. So temp equals temp.append node.val. So temp equals temp plus node.val. Oh, fuck. My ribs are fucking destroyed. I don't know why. It actually hurts like crazy. Node.left, node.right. Let's run that. Yeah, you see, my code was all correct except for this one condition here. I didn't even have to change anything except for this one little condition here. All it does is instead of appending it if there's a node.left, right? Because we're using the final node as the check to add, that means it doesn't matter in any case whether it's left or right. In any case, if we keep coming back and recursing, we add temp plus node.val. So my code was still correct for the most part. See, my logic, everything made sense. The way I add arrows made sense. So like all this logic is correct except for this portion here. So like overall, I would say I did a pretty good job. Just like working through my thought process, working through the whiteboard, like you could still come to a solution, right? Like, sure, I didn't use a fancy DFS method, but still got it, right? Still got it. So if you like this video, please give it a thumbs up, subscribe, and leave your comments below. Tell me what you guys think. See ya. Knologist out.